Okay, so let's talk about a few things. Now I'm almost back to Blackhat. I'm not sure when I'm going to push this video, probably before I go. But I wanted to record a few things before I go. I will be out for a while, and then I'm going for a vacation. So yeah. Now, let's talk about a few things, and not so obvious things. Lately, we've seen a few prominent security-based software houses or companies, not all of them just exclusively about software, most of them sell equipments as well, that are being in the fire. Now, every piece of software has bugs, and some of those bugs will have security implications. That is how I see things. I work in security. I like to pwn things. I like to break things. I like to find bugs on things. They are as close to a puzzle for the common person, I would say. Everyone else that doesn't do this for a living. That's what I mean. And in contrary to some colleagues that I know, which I don't think there's actually no correct way of seeing this. I guess this is a personal preference, really. I've been too long on the software side to actually believe or to have a different perspective. Software will have bugs. That is to be expected. Some of those bugs will have security implications. Others will have stability implications, or are just going to be plain, just unwanted features, I would say, or bad behavior, unexpected behavior, or expected, depending on how familiar with the code you are. Some of them are related to use cases, and those are the most interesting ones to solve from a developer standpoint, if you like to solve problems. Now, what we have most of these days is the fact that people like to build things. They don't like to solve problems, and I think that is issue number one with software. That's why everyone is so happy about the fact that there are things now that can help you generate code. It will help you to get something working faster. It might. Is the code decent? I doubt it. Is the code maintainable? Not really. I would say no, based on what I've seen. But I will not hold my breath on this. But so what I want to go with this, reach with this is, if you like to solve problems writing code, right? You like to write code yourself, right? You also have your own way of writing things, right? So describing something and then coming up with the code is fun to see it happen, but the thrill is building it yourself. Now, call me old-fashioned, since that's less productive. I don't know. I'm not in software development anymore. I do believe that if you think for things and if you build it yourself, build it carefully, and this usually takes a while because use cases generally conflict with each other. Then you're going to end with something that, in order to change, if you have to change something or if you have to fix something, you will have to touch the least amount of code possible, right? And that tells you how maintainable that code is. And if you need to change something and all of a sudden you need to change 62, 63 classes, like I had one day, to fix one of 30 problems in a bank's middleware that was built in Java. Like the first commit was 62, 63 classes. That is far from being maintainable, especially considering that it was just addressing the fact that no one was closing file streams. It ended up starting as a private joke because there was someone in there that thought that the garbage collector was meant to close file streams. Now, going back onto what I wanted to see to talk about, by the way, was security-based products with ridiculous issues, right? Hard-coded credentials inside. There's always that pushback, backdoor, not backdoor. We really don't have a way of knowing. They might say there was an issue with the build. There's management, testing, instrumentation, whatever excuse they may come up with. The core of the issue is, if it ends up in production, it gives you privileged access to a device. It's at the back door. It might not be an intended one, it might not be on purpose, or it might be, right? You might have, you might be having someone getting kickbacks to leave things behind, or to deliberately forget about things in the code. That was a description that I heard from someone that works in the banking industry here in Portugal once. It was really funny. We were looking for rogue Wi-Fi's once. It was a cool story. That was a cool story, by the way. But back on topic now, we have a few things. I don't want to go too deep on these bugs, because if I'm going to do that, the goal would be for me to just build a damn exploit, I would guess. So I'm not going to. There are a lot of places where they go drill down on these things. I just like to highlight a few ridiculous things. Remote code execution that would give you a root level access privileges. Now, I'm not surprised that Cisco's identity management would face such a bug, mainly because I've seen this before, right? I've audited once, financial institution once, and we got in through the guest Wi-Fi by breaking the authentication portal that was running on a rip-off of Tomcat. And I call it rip-off because it was highly customized. It was still Tomcat, but it was butchered a lot. It had a lot of stuff being pulled off, and weird stuff pulled in. But it was running as root. It was running as root, and the way the equipment and the network and everything else was laid out together led us to a very privileged position inside the network. We had basically access to the entire thing. Through we had access to a trunk, so we could hop into anything we wanted. From that point, it was pretty cool. It was a very, very, very old bug, even then. So that usually one of the things that I usually listen into in training is, this bug is really old, that bug is really old, when we want to highlight a specific set of bugs. And usually the old ones are easier to trade or easier to understand because they're simple, right? There's not much in the way yet. People always get that word, and I try to steer myself away from debating that, and calling out the obvious. If you don't have contact, never had contact with this, it will help you for sure. Because these bugs do happen from time to time. If not, well, if you're already aware of it, just go ahead. Life's too big. But it is odd. I'll summarize my point with these links, which is something I usually don't do soon. So I'm going to jump straight into this one here. Now this is from the latest one. And the latest hit that Fortinet took. Now, Fortinet took in the fire. At this point, I'm clowning around with a few colleagues of mine because I've been talking about pulling IoT for a spin for some time now. And time has usually been in the way a lot of times. And every time a bug like this shows up, I've been like, damn. I lost another opportunity to find a cool bug. Now these are, dude. I'm expressing myself in ways that I'm going to get in trouble. But come on. SQL injection, like plain SQL injection. Okay, this is C, but come on, like. I have to say it. We are in 2025, right? Are we still battling these things? Really? Like, is the development team in such a rush, right? Because I don't believe that anyone in development these days is naive enough to think that this is acceptable, even if you're not coding PHP. Okay, we know PHP is known for these things, and others equally embarrassing, I would add. But come on, right? This is old stuff. OWASP, try harder. I mean, it could at least make it harder than a CTF, right? And it's not going there. It's not going there. So this is the write-up by Watchtower Labs. They have here the patch diff. Here this is the code they added. And this is how it was before. So it's just straight in argument concatenation into SQL. There is no reason whatsoever. None. Zero. Okay. Arguments for someone to concatenate queries. Period. Okay. It's plain laziness. I said it, and I said it before. There is no reason for it. Laziness is due, and that's pretty much it. And then the scariest of them all, okay, is UEFI, firmware-based attacks. Now, these are bloody scary. They're scary as hell. Not just because we might be talking about something that is not easily analyzed. Like, it needs a lot of skill, and it needs a lot of time, okay? And it goes bluntly unnoticed, and it goes like that because these days everyone's running away from C, let alone pulling firmware apart, okay? Like real firmware, like biased firmware, like low-level stuff, the stuff that manages all your interfaces and all your all the other stuff that is plugged to the motherboard, really. Your graphics card, you name it, right? If it's plugged to the board, that is where those things are going to be managed. I even lost my words there. But it is true, right? It is true. It's really tough. And the skills here from another level, right? It needs a lot of patience. And I'm not the kind that thinks that, oh, this is beyond, it's only for a few. Like, it's only for a few patient minds with enough time. If you can be really efficient if you do it enough. But the thing is, you need to invest significant amounts of time to be really efficient at this level, right? And you need significant amounts of knowledge, not at the same level like cryptography, that is not for everyone. Yeah, you need to be really good at math, and that alone will get that list pretty damn short. I don't want to go too deep on this one here. It's a bluntly worrying issue, not just because it is around a piece of equipment that manages pretty much anything that you have on the computers, the motherboard, right? It's where everything starts. And the fact that vendors these days have an extremely short TTL, and that to me, the worrying part here is I have a few motherboards from Gigabyte around. And I'm fighting problems with write driver. I think I've patched it twice. The original chipset is by AMD, and I'm probably going to consider dropping it because every time a new kernel version pops up, I need to patch it. And the last patches I made, I'm already getting a lot of warnings in the code because it was not compiled with with the latest things on code protection, and the kernel is getting those flags now. And so there's a mix match, and it's a ride, right? It's managing your data drives. So I'm getting a bit cold feet on that front. But that is actually somewhat related problem. Software and hardware these days want to push product out. That's their main goal. And after 1 year, 2 years, updates will stop. You only have updates for critical vulnerabilities, and in order for you to get that critical vulnerability patch, it needs to be either really noisy, make the company look really bad, like a really nasty bug, or needs to be significantly higher, like in the scale, like an 8.5 or more. Otherwise, it's going to be mainly due to pressure. But that is because the time that the TL, the time to live, is shortly shortly after warranty. Things will stop. Like there will be a stop into development. And the same goes for software, right? But motherboards are one end. They're worrying. This is not new. It's the same problem as we have with IoT. You buy it. After a while, there's hundreds of vulnerabilities in it. Nobody knows who built it. There's some weird land that nobody knows where it is. It went through a number of resellers until it reached the one that puts a brand on it. And that's it. No, this is not. And this is how things are built these days. This is not brand A, brand that, or origin X or origin Y. It's just how things are made these days. It's basically market-based alignment. Then we have here the almighty SharePoint, right? This is a serialization issue on view state abuse. Interesting fact, and this is also somewhat related to. This is also somewhat related to what some technologies here like to basically find clever ways of sharing the load on the server side and client side when they want to work with state. It takes a lot of skill to find the right balance and to actually create something stateful with a stateless technology behind it. And so serialization is one of the things that ends up on the table one way or the other when that happens. So I'm not surprised. I'm surprised to see that Microsoft and SharePoint, which has been around for a while, right? In latest years, we haven't seen that much prominent issues. Like there have been a few, right? It's not that many proof of concepts with a few criticals. But I might be wrong because I spend most of my time in infrastructure. Haven't looked that up that deep. The one thing I would like to add, though, and I like to talk about this on this video, is the fact that the first here and the Cisco and the Fortinet are the main attention grabbers. Cisco is a prominent network and security somewhat related company, right? They make routers, switches, firewalls, and then some, because they acquired a bunch of other companies in a way as well. You got Splunk, and I think that changed his name right now, but it's one of the tools to get to pull signal from the extremely noisy place that is a network. And Fortinet has a lot of 40 based products, right? 40 whatever, 40 router, 40 firewall, 40 gateway, 40 whatever, right? They take 40 in as a prefix on every single product they create. but it is their focus. It's basically managing the front line, right? Or somewhat front line, depending on this. It's not meant to be for extremely big companies. There are others, but we also have seen that happen for other prominent names, right? It's not. I clown around a lot about CrowdStrike, right? And I do think that was extremely ridiculous. But that is one of the examples, right? It's not it's not a single case. And so when we acquire a piece, something from a company that is meant to help to protect the environment or the infrastructure, right? The last thing you want to see is an SQL injection, right? And I think that is not just because everyone is really, really, really pushing to have a lot of product being pushed out all the time at the same time at an insane rhythm. A lot of it is due to the culture that it's shift that is happening, right? Most of software developers these days are not keen to solving problems, right? They like to create things, and there's a difference in there. If you like to solve problems, you like to thrill and the rush of building things yourself, right? Writing the code yourself, thinking about the problem. It's like solving a puzzle. When you have a bug, it might have security implications. It might not have security implications. Bugs are bugs. And not every software developer is security inclined. So they will understand it. It's not their focus. Their focus is elsewhere. Right, and that's completely natural. But the last thing you want to see is ridiculous bugs like that, CTF level bugs popping up on your firewalls or on your endpoint or identity management. That's not right. That's clearly not right. And someone is skipping testing in QA, I would say, by a lot. And so one of those things is related to that. So since your drive is not to solve problems, right? You're going to want to delegate that. And I think that is also the reason why everyone's got so happy with code generation tools that we're getting right now, right? I'm sure that there will be good things coming up from there. Or won't. I don't know. But how good will that be? I'm a bit on the defense side on that thing. My definition of a solid code is one where when you need to change something, the end result is going to be you're going to need to touch as little code as possible. Okay, if you need to change half the project just to change one simple behavior, chances are that's not made correctly, right? If you need to build an entire API to make sure that you don't have SQL injection related issues, that doesn't smell right, and especially considering that you already have one called prepared statements. Now, are they bulletproof? Not really. There are a few edge cases. But that has been the philosophy till now, right? There's a lower APIs being battle tested and tested over an extended period of time, and then you have something that relies on top, which is usually has a different approach to it. It's more volatile, right? The web applications, the volatile stuff, and so. Having a code generation tool, I don't think that will end up resulting in a very manageable piece of code, but I might be wrong. But the focus is now on producing a lot of stuff in a short amount of time, and that, regardless of how you create it, will always lead to a lot of interesting feats. Now we are all waiting on this side to have an opportunity back to exploit things left and right. And so we usually greet those CVEs with great happiness. And that is going to be it. Now, I'm preparing a few things. Actually, sitting next to me is a 48 core monster with 4 CPUs. So there will be a few things. Actually, I might I'll record a series of videos of preparing the lab, preparing that into a full-blown lab, the way I usually do it. It's going to involve a lot of automation here, and so I'm going to do that. In the meantime, have fun. Take a look at those things. If you like IoT, or you like to write exploits, I would say take a hit at it, because I think it's going to get interesting, and I think the technology we're using to create these things, or at least maintaining them feature-wise, it's going to lead to a few interesting CVEs. So till then, have fun. See you around.